To debug faster and better with Flipper, establish a better feedback loop by implementing Flipper and have more fun while working on your app. Issue you are using Chrome debugger or some other hacky way to debug and profile your React Native application. Debugging is one of the more challenging parts of every developer's daily work, and finding out what is wrong can be very frustrating. We usually try to fix bugs as soon as possible, especially when they are critical, and make an app unfunctional. Time is an important factor in that process, and we usually have to agile to quickly solve the issue. However, debugging React Native is not very straightforward, as the issues you are trying to solve may occur on different levels. Namely, it may be caused by JavaScript, your application's code, or React native code, third-party libraries, or React Native itself. When it comes to debugging native code, you have to use tools built into Android Studio and Xcode. When it comes to debugging JavaScript, you may encounter several difficulties. The first and most naive way to debug is to write console.logs in your code and check the logs in the terminal. This method works for solving trivial bugs only, or when following the divide and conquer pattern. In all other cases, you may need to use an external debugger. By default, React Native ships with built-in debugging utilities. The most common one is Google Chrome Debugger. It allows you to set a breakpoint in your code or preview logs in a handier way than in a terminal. Unfortunately, using the Chrome Debugger may lead to hard to spot issues. It's because your code is executed in Chrome's V8 engine instead of platform specific engine such as GSC or Hermes. The instructor generated in a Chrome are sent via WebSocket to the emulator or device. It means that you can't really use the debugger to profile your app, so it detects the performance issues. It can give you a rough idea of what might cause the issues, but you will not be able to debug the real issue due to overhead of WebSocket message passing. Another inconvenience is the fact that you cannot easily debug network request with Chrome Debugger. It needs additional setup and still has its limitation. In order to debug all possible requests, you have to open a dedicated network debugger using the emulator's developer menu. However, its interface is very small and is inconvenient due to the size of the emulator screen. From the developer menu, you can access other debugging utilities such as Layout Inspector or Performance Monitor. The latter is relatively convenient to use, as it is displaying only a small piece of information. However, employing the former is a struggle because of the limited workspace it provides. Spending more time on debugging and finding performance issues means a worse developer experience and less satisfaction. Unlike native developers, the one working with React Native has access to a wide range of debugging tools and techniques. Each originates from a different ecosystem, such as iOS, Android, or JS. While it may sound great at first, you need to remember that every tool requires a different level of expertise in the native development. That makes the choice challenging for the vast majority of JavaScript developer. Inconvenience tooling usually decreases the velocity of the team and frustrates its member. As a result, they are not as effective as they could be, affecting the quality of the app and making the releases less frequent. Solution: turn on Flipper and start debugging. Wouldn't it be great to have one comprehensive tool to handle all of the above use cases? Of course it would. And that's where Flipper comes into play. Flipper is a debugging platform for mobile app. It also supports React Native as plus class citizen. Launched in September 2019, Flipper has been shipped by default with React Native since version 62. It is a desktop app with a convenient interface which directly integrates with your application CS and native code. This means that you no longer have to worry about JS runtime differences and the performance caveats of using the Chrome debugger. It comes with a network inspector, React Dev Tools, and even with a native view hierarchy tool. What's more, Flipper lets you preview logs from native code and track native crashes, so you don't have to run Android Studio or Xcode to check what is happening on the native side. Flipper is easily extensible, so there is a high chance it will be enriched with a wide range of useful plugins developed by the community. At this point, you can use Flipper for tasks such as detecting memory leaks, previewing the content of shared preferences, or inspecting loaded images. Additionally, Flipper for React Native is shipped with React Native Dev Tools, Hermes Debugger, and Metro Bundler integration. What's most exciting is that all the needed utilities are placed in one desktop app. This minimizes context switches without Flipper. Developer debugging is an issue related to displaying the data fetched from the backend had to Use the Chrome debugger to preview logs in emulator network request debugger and probably in emulator layout inspector or standalone React Net React Dev Tools app with Flipper. All those tools are available as built-in plugin. They are easily accessible from a side panel and have similar UI and UX. You have more fun working with React Native and establish a better feedback loop. A better debugging process makes your app development cycle faster and more predictable. As a result, your team is able to produce more reliable code and spot any kind of issues much easier. Having all the debugging utilities in one interface is definitely ergonomic and does not disrupt any interactions with any emulator or device. The process will be less burdensome for your team, and that will positively impact the velocity of the product development and bug fixing. Avoid unused native dependencies. Improve the time to interactive of your app by removing the linking of unused dependencies issue. You have a lot of dependencies in your project, but you don't know if you need all of them. Every bit of native code we use in our app has a runtime cost associated with reading, loading, and executing said code. The more native dependency our app have, the slower it is for apps to start, which impacts the TTI metric and makes your user wait more to start interacting with your app. In our React Native app, we often rely on dependencies that load Kotlin, Java, Swift, Objective-C, and JavaScript, and recently more often even C++. Those dependencies are declared in the package.json file, which allows for a JavaScript bundler to correctly discover and well bundle their JS parts into the final application. It may be counterintuitive at first, but this declaration in the JavaScript toolchain influences the native side as well. And the reason for that is the auto linking feature of React Native CLI. Auto linking allows us to link native dependency in React Native automatically without ever touching native tools like CocoaPods and Gradle. If you are not familiar with how Android or iOS toolchain works in terms of using external dependency, you might be asking what's linking native dependency when dealing with native binaries, be it either in C, C++, Objective-C or Java. Linking is a way for native toolchain to understand where to find the actual code that associated with the third party dependency we want our code to use. What's important is that it's necessary, and for a long time we React Native developers needed to do this step manually. Since React Native 60, we have an automated way of doing this thanks to the React Native CLI. One more important thing to know about how auto linking work is that it crawls your package JSON and then node models in search of native code. The tool doesn't know whether you are actively using the library that ships native code or not. It will be linked anyway. What does this mean? All the native dependencies will be linked and available in your app bundle. As a result, we will end up with an increased bundle size and degraded TTI, as the mobile OS will spend more time loading the native binary, showing your users a splash screen. A bit longer solution: find and remove unused dependencies. To find unused dependency in our project, we can use the depth check library. It is a great tool for analyzing the project dependency to see how each one of them is used, which dependencies are useless, and if which dependencies are missing from package JSON. To use depth check, we need to run npx depth check in the root of your project. For a project, an example of the result looks like this. Dev dependencies likely won't end up in the JS bundle unless there is a native code inside. So in this example, there is no need to focus on them, but the result can show us that we have few unused dependencies. And what's more important in this case, these dependencies are relying on some native code. Now we have to remove them, and it's done in the example app. Removing unused dependency from screenshot above occurred with the following result in the bundle size. It's worth mentioning that on the Android device there was a noticeable improvement in the time to interactive, which was reduced by 17%. In this case, you may be wondering how we can measure the TTI. There are few ways to do this. Whichever you choose, remember to always measure on release version of the app when dealing with absolute number. One way is to use stopwatch and measure the time the app took to show the first screen. As shown here, it's entirely manual, but it will often get the job done for one of measurement. If you want to get a more detailed output, we can make use of Perfetto for Android. For iOS, we can enable performance monitor from the dev tool and double tap on the monitor window to expand. The output will look like this. We can also use app launch from Xcode instruments. All you need is to install a release build through profiling to your real device, then select app launch from the window that will appear automatically once the build is installed. Hit the record button, and once the app has launched, stop recording. You will get an output similar to this. There are two phases when calculating app launch time on iOS. The first one is called pre-main time, and it's time before the main function of the app is executed. It's marked with the purple area on the graph above. All the work needed to launch the app correctly, like initialization, linking of libraries, happens in this place. The second phase, called post main time, is the time between executing the app's main function and presenting the first interactable view to the user. It's marked with green color on the graph above. The total app launch time is sum of both of this metric. If you want to learn more about testing app launch time, here's a good read on this topic. It's worth mentioning that there are a lot of third-party tools helping developers to get bunch of performance information from apps already submitted to Google Play and App Store. The most popular Firebase performance monitoring, Sentry, and Datadog. The key advantage of using these tools is gaining data about performance from many different devices. Benefits: a smaller bundle size and faster time to interact. Removing a few unused native dependency ended up reducing both size of the app bundle and TTI by around 17%. Providing only resources needed by the app can improve time to interactive metric, making user less likely to uninstall your app from their devices due to excessive load time. It's worth remembering that although auto linking is great and powerful feature, it can be overzealous when it comes to linking code our app doesn't really use. Make sure to keep your dependencies up to date and clean up unused ones during refactoring. So yeah, that's it for today's video. Thank you for watching. Bye.